For 2 years, astronomers kept finding these tiny red dots in James Webb images, hundreds of them, just scattered everywhere in the oldest and most distant parts of the universe. They started showing up in the very first data released back in 2022, then more and more through 2023 and 2024. One survey, called RABBIS, pointed the scope at 4,500 galaxies and found 35 of these things just sitting there in the data. The name they gave them? Little red dots. That's the actually scientific name, I'm not making that up. Now, here is why this mattered. These dots seem to break our understanding of how the universe actually works. For 4 years, the biggest fight in astronomy was about a bunch of red pixels that nobody could explain. Then 6 days ago, on June 10th, 2026, a team finally figured it out. And honestly, what they found inside those dots is so much weirder than what anyone was expecting. Okay, so first, why did nobody see these things before? It comes down to what Webb can do that no other scope could. Webb sees infrared light. That's the old light, the ancient stuff, light that's been traveling for the over 12 billion years and got stretched out along the way. Hubble just couldn't pick that up. These objects were completely invisible to it. When Webb switched on, it was like going from a blurry security camera to a 4K view in the beginning of the time. And suddenly, there were red dots are all over the place. Okay, by summer 2023, astronomers had noticed 3 weird things that all these dots had in common. First, they were tiny, seriously compact, way smaller than you'd expect. Second, they had this bizarre V-shaped spectrum, blue light on the side, red on the other. Nothing else in the universe does that. And third, they had these crazy wide hydrogen lines in their spectra. That means gas around these things was moving at thousands of kilometers per second. Whatever was going on inside them, it was violent. So you've got 3 clues and 0 answers. Okay, so here is where it really gets scary. Those wide hydrogen lines, in astronomy when you see that, it almost always means one thing. There's a supermassive black hole in there. Gas whipping around at its insane speeds because something enormously heavy is pulling it in. But the problem is, these things existed when the universe was only about 600 million years old. And the universe is 13.8 billion years old. So 600 million years, that's nothing. That's like the first 3 weeks of someone's life. The universe was basically a newborn. And supermassive black holes, they are not supposed to exist that early. That's not how they work. The way we thought it works is, a big star dies, it leaves behind a small black hole, maybe 100 times the mass of our sun, and then over billions of years, that black hole slowly pulls in gas, eats, grows, gets more massive. Eventually, it reaches millions or billions of solar masses. But that process takes a really long time. And then Webb shows up and finds black holes that are already 50 million times the mass of the sun, sitting in a galaxy that barely even has any stars yet. When the universe was basically still in diapers. There just wasn't enough time for them to get that big. The math straight up didn't work. So some scientists started saying maybe our models are wrong. Maybe we don't actually understand how the universe works. Others had a different idea. What if some black holes were just born big? What if instead of starting as a dead star, a huge cloud of gas just collapsed directly into a black hole, keeping the star phase entirely? They call this direct collapse black holes. Cool idea, but nobody could prove it. And then along came one very specific little red dot called Glimpse 7775, sitting behind a massive galaxy cluster called Abell S1063, about 12 billion years from us. This thing existed when the universe was only 1.8 billion years old. Now here is the clever part. The galaxy cluster between us and the dot, its gravity bends light. It works like a natural magnifying glass. Astronomers call it gravitational lensing. And in this case, it took 30 hours of scope time and basically turned into 80 hours worth of data. The universe handed them a free upgrade. So Vasily Kokorev and his team at the University of Texas at Austin pointed Webb at this one dot and got the deepest, most detailed spectrum anyone has ever captured of a little red dot. Over 40 spectral lines, hydrogen, oxygen, helium, you name it. Going from the old data to this was like going from a blurry phone photo to a full CT scan. And what those 14 lines showed them. This thing is not just a black hole, and it's not just a star, it's both. A supermassive black hole sitting at the center, completely wrapped in a massive cocoon of hot, partially ionized gas. Think of it like a star, except instead of being powered by a nuclear fusion like our sun, it's being powered by a black hole that's eating it from inside out. They're calling it black hole star. And yeah, that's as wild as it sounds. So how does something like this even form? How do you get a black hole inside a star? Think about the early universe. No stars, no galaxies, nothing. Just enormous clouds of primordial gas floating in the dark. Now, one of these cloud stars collapsing under its own gravity. The core gets denser and denser, and instead of lighting into a small star, it's so massive that the core just collapses straight into a black hole. But here's the thing. The outer layers of this cloud are so unbelievably massive that the energy from the black hole forming doesn't blow them away. They absorb it. They hold on. The envelope survives. So now you've got a black hole trapped inside this giant gas envelope, and it starts eating. It pulls gas in through an accretion disk, devouring up to several solar masses worth of material every year. And the energy coming off that feeding process is what keeps the whole outer envelope puffed up, like a balloon being inflated from the inside. The thing swells to over 100 times its original size. From the outside, it just looks like a big glowing star, but at the core, it's pure darkness and is getting hungrier. Now here is the detail that actually cracked the whole mystery. Remember those wide hydrogen lines everyone was seeing? The ones that made people think giant black hole? Turns out the new spectrum proved they weren't caused by a gas orbiting a black hole at all. They were caused by electron scattering. Basically, photons were bouncing around inside the dense cocoon, picking off electrons, getting scattered in every direction. And that scattering is what made the spectral lines look so wide. That's a huge deal, because it means all those earlier mass estimates were wrong. We were looking at the cocoon's distortion and reading it as black holes as mass. The universe was never actually broken. We were just reading the data wrong this whole time. But wait, there is one more thing. These black hole stars only existed for about a billion years. They appear around 600 million years after the Big Bang. And by about 1.6 billion years, they're gone. All of them. Not a single one left. So what happened? The leading idea is that the black hole eventually won. It ate through its own cocoon. It consumed the disuse. And once that gas cleared the way, it wasn't hiding anymore. It wasn't a red dot. It was just a black hole. Out in the open, blasting jets of energy into space. What we'd call a quasar. So these things didn't die. They transformed. They shed their cocoon like, I don't know, some kind of cosmic metamorphosis. And think about what that means. Every supermassive black hole at at the center of every galaxy we've ever looked at, including the one sitting right in the middle of the Milky Way, 4 million times the mass of the Sun, might have started exactly like this, as a little red dot, a disused monster, quietly growing in the dark, billions of years before our planet even existed. We spent 4 years looking at the red dots and thinking something was fundamentally wrong with our picture of the universe. Turns out we just needed a closer look. One dot, one spectrum, 40 lines, and suddenly the first chapter of the universe made sense again. The first monsters out, they weren't galaxies, they weren't stars, they were something we never imagined. Stars with black holes for hearts, and we almost missed them. If you want to see the next mystery the universe is hiding, hit subscribe. Next time, something even stranger, buried in Earth's own past.